One of my fondest memories is playing at the beach back in Taiwan. My sister and I collected horseshoe crab shells and played in the surf. I want to ensure my kids will be able to have this exact same experience. Inspired by this story, I was excited to participate in global environmental action. I had learned about microplastics in our oceans and I wanted to help out any existing initiatives. However, there wasn't really any way to do that. This is why I am proposing the Microplastics Citizen Science Kit. It will be a way for high school students like me to make an impact against microplastics pollution in our oceans. Covering 70% of the planet's surface, the oceans are home to Earth's most diverse ecosystems. From small coastal communities to the international market, the ocean and its organisms provide food, water, transportation, materials, and much more. Unfortunately, our oceans are being attacked by man-made invaders, microplastics. Microplastics are tiny plastic particles that range from 5 millimeters all the way down to 1 micrometer. These debris can cause all kinds of havoc, delaying growth, reducing reproduction, poisoning, or even genetically affecting all kinds of marine life. While it is largely accepted that microplastics cause significant harm, it is hard to pinpoint and study their exact effects. This is because the size range of plastics is really large, and existing studies have not provided specific data. It would be like comparing the taste of a smoothie to fruit salad. Both have the same ingredients, but the sizes of the ingredient particles make a huge difference. Previous initiatives have focused solely on the number of plastics per unit water, but those numbers could be particles of such drastically different sizes that the data will not be as effective. This is where the kit comes in. Unlike other attempts at citizen science, it contains multiple filters to differentiate between sizes of microplastics. Students will be able to use these filters, along with their school microscopes, to count the number of each size of plastic, then log the data along with location, time, and date to a website, which scientists will be able to access and utilize. The kit will also include an educational booklet with lesson plans and extra resources to learn about marine life and the impacts of microplastics. In this way, we can simultaneously help students learn science and empower them to contribute to a global environmental initiative. Since these materials are pretty cheap, the first few kits can be donated to schools along the coast to start the movement. However, this initiative can easily scale to become a non-profit organization that sells kits to schools around the world. Any revenue generated from the kits would be reinvested into better kits, microplastics research, and other marine debris removal initiatives such as the ocean cleanup. With this idea, we can start a movement with the scientists of the next generation. Just like the hole in the ozone, we will purify our seas through education and global action.